in addition to scalar multiplication, we can also multiply two matrices together, okay? So there is a rule, okay? You can't just multiply any two old matrices together, okay? Remember when we were adding and subtracting, there was a rule. In order to add or subtract two matrices, they had to have the same dimensions. Well, there's a separate rule for multiplying two matrices, and it's a little more complicated, okay? So it says right here, in order to multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. Okay, very, very important. Okay, that is the only way you can multiply two matrices. The number of columns in the first matrix must equal the number of rows in the second matrix. Okay, we can read this little blurb. It's very mathy. I'll show you a little shortcut, so don't rely too heavily on trying to memorize this statement. Okay, so it says if A has dimensions m by n and B has dimensions n by p, then we can find A times B, and the matrix A times B will have dimensions m by p. Okay, that's a lot to take in. Like I said, I'm going to show you a little shortcut that you don't even have to memorize that statement. Okay, but just keep in mind you've got this rule that you have to abide by in order to multiply two matrices. Okay, in the second bullet point, it says matrix multiplication involves finding something called a dot product. Okay, dot products of rows and columns. We find the dot product of a row and a column by multiplying the corresponding elements and then adding the results. Okay, so basically, if your matrix multiplication is defined, like it says here, it's going to involve, to get the numbers inside the product, you're going to have to do a bunch of something called dot products. So at the top of page 4, I have an example of a dot product, okay? So example 6, it says find the given dot product, okay? So it's what I have here, it looks like two matrices, and these are matrices right here. I've got a little dot in the middle, okay? And I'm trying to emphasize there that this is a dot product example, okay? I'm just trying to give you an idea of how this process is going to work. And then in example 7, we'll actually start multiplying matrices together, okay? So this is how it's going to work. You always do the dot product of a row and a column, okay? It's always a row and a column, okay? So what you're going to do is multiply the corresponding elements together, okay? So I'm going to take the first number in each. So the 5 here and the 3 here. And I'm going to multiply those guys together, okay? So 5 times 3, okay? Then I'm going to take the next set of corresponding elements. So do the middle guys, 0 and 6. You're going to multiply those together. So 0 times 6. And then lastly, take the last elements, -2 and -4. Multiply those together, okay? And then we're going to add the results, okay? So this is going to be 15 plus 0 plus +8, and the dot product is the number 23, okay? So for example, if we had larger matrices, and this was the row and the column you were working on, okay, doing the dot product of that row and that column would produce the number 23 to go into your product matrix, the matrices you're multiplying together, okay? So that's what a dot product is, okay? You take corresponding elements between your row and your column, you multiply the corresponding elements together, and you add them all up, okay? Like I said, it'll make more sense when we start doing this. All right, let's start an example here, okay? In example 7, we're going to start multiplying matrices, okay? Above example 7, there's a little blurb, okay? Again, it's very mathy, so it may not make a lot of sense. The little blurb is about, matrix multiplication. When multiplying two matrices A and B, provided the multiplication is defined, the element in the ith row and jth column of A times B is the dot product of the ith row of A and the jth column of B. Okay, so that's very, very mathy. Okay, that's the rule. Okay, I'm going to translate all of this for you so you can see how this works. Okay, all right, let's start doing matrix multiplication. In example 7, okay, it says perform the indicated operation if possible. Remember, some of these may not be defined. The first thing you're going to have to check to see is if it's even possible to do the multiplication. All right, so remember, here we go. In example A, we've got these two matrices, okay? We've got to check to see if this is going to work, okay? So remember the rule. The number of columns in the first matrix must equal the number of rows in the second, okay? So this is how I want you to do this, so you don't have to keep running that statement through your head, okay? All you need to do to check to see if you can multiply two matrices is this, okay? Write down the dimensions of each, okay? So when I look at this first matrix, it has 2 rows and 3 columns. So this is a 2 by 3 matrix, okay? And then the second matrix, it has 3 rows and 1 column. So it's a 3 by 1, okay? So remember what the rule for matrix multiplication is, okay? You're allowed to multiply them if the number of columns in the first matrix, so when you look at this matrix, the number of columns, it has 3 columns, the number of columns in the first is equal to the number of rows in the second, okay? It has 3 rows. So all you need to do is write down the dimensions of each and check to see if the inner numbers match, okay? Because this number right here is referring to the number of columns in the first, and then this number is the number of rows in the second. So as long as these two numbers match, you're good to go, okay? And what's great about doing it this way, okay, these outer numbers, this is going to tell us the dimension of the result, okay? So the resulting matrix, when you multiply these two guys together, the resulting matrix is going to be a 2 by 1 matrix, okay? So let's do it, okay? Let's multiply these guys together, okay? So this is what I want you to do, okay? You check to make sure, check those inner numbers that they match. That indicates, you can do the multiplication, okay? The outer numbers give you the size of the result, okay? What I want you to do, okay, is map out the result, like set up a little template here, okay? I'm going to get something that has 2 rows and 1 column, okay? So just map out what you're expecting, okay? If you do this, okay, it's going to help you. You won't lose your place. It's very easy to get lost when you're doing this matrix multiplication, but if you kind of map it out, like I'm going to end up with something with 2 rows and 1 column, you've got it kind of laid out. It's not as you're less likely to get lost doing this. All right, so let's go ahead and do this. Okay, this is the way it's going to work. Remember, it's going to be a bunch of dot products. Okay, so let's start in the result. Okay, in the result, okay, this first spot in the result, this is the first row, first column. Okay, so that means we're going to go over here and we're going to do the dot product of the first row in the first column. Okay, so one more time. This position in the final matrix, the matrix that we're constructing, this is the first row, first column. You're going to do the dot product of the first row, first column, what I have highlighted there, okay? So that means you're going to take the corresponding numbers, multiply them together, and then add them up, okay? So let's multiply the first numbers together. You're going to get 1 times 4, okay? Then the middle numbers, 3 times -2. And then the last numbers, 1 times 4, okay? And then you add them all up. Okay, and then if you simplify that, okay, this is going to be 4 minus 6, that's -2, plus 4 is +2. Okay, so we're almost done. We just have to get the second element. All right, so then moving on, okay, in your matrix product, okay, this is located in the second row, first column. So now I'm going to do the dot product of the second row, first column. Okay, so it's going to be multiply the first numbers together, so 3 times 4, okay, do the middle numbers, 1 times -2, multiply the last numbers, 3 times 4, add them up, okay, so this is going to be 12 plus a -2, that's going to be 10, plus 12 is going to be 22, okay. Here is the final answer. When you multiply these two matrices together, okay, this is the matrix that is produced. All right, let's try another one. Okay, let's look at example B here. Okay, here are the two matrices we're going to multiply together. Okay, first thing, gotta check to see if you can even do this. Okay, so write down the dimensions. This first matrix has 3 rows and 1 column, so it's a 3 by 1. And then the second matrix has 2 rows and 3 columns, so it's a 2 by 3. Okay, so remember, you need to check the inner numbers. Okay, this is the number of columns in the first matrix. Does that equal the number of rows in the second? These numbers do not match. Okay, so it is the number of columns in the first does not equal the number of rows in the second. Okay, so you cannot perform this multiplication. Okay, can't do it. Can't multiply these two together. So all you need to write down here is that this matrix multiplication is undefined. Okay, let's try another.